Welcome to another edition of Sudoku and Variants, where I teach you how to solve Sudoku and Variants the easy way. Today we have a butterfly Sudoku. This is similar to musketry and to Sudoku. The difference is that in butterfly you have four 9 by 9 grids overlapping here, 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 and here. The rules are that the numbers 1 through 9 must be placed without repeating any number within the same row or column in any 9 by 9 grid. Or repeat any number within a 3 by 3 grid. The outer goes over to the fourth grid, still applies as a solving technique. Here you can apply that technique even to the outer fourth grid. This means that the 2, 4, 7 in column 12 will have the same numbers in this fourth grid on the bottom some order. Here we see 2, 4, 7 on top and 2, 7, 4 on the bottom. If we were to look at row 1, we see a 2, 9, 8 combo. I can use this rule outer goes to the fourth grid and know that the fourth grid will have the numbers 2, 9, 8 in some order. Here, when we look at the fourth grid, we see a 9, empty square 2. We know that we must put the missing number 8 here, as this is the number in the first 3 squares. Row 2 has a empty space 5, 6. I know that the fourth grid will have a 5 and a 6. 6 at least. I look at the fourth grid and find a 4 but no 6. I can safely put the 6 in this square in the fourth grid and put the 4 in the first square in row 2, column 1. Now if we were to look at column 12 and then count the numbers in the order, we will see we have 1 through 9 without any repeats. One, two, three, four, five, 6, 7, 8, 9. Any repeats for the upper 9 by 9 grid. Then if we do the same counting for the lower 9 by 9 grid, we still see no repeats. One, two, three, 4, 5, 6, 7, 8, 9. Notice that the outer grid in the upper rows 1 through 3 is not a part of the lower 9 by 9 grid. The lower rows 11, 10 through 12 is not a part of the upper 9 by 9 grid. This means that the middle six numbers are not repeated in any row or column. The 8, 3, 6, 5, 1, 9 is the same in the same order in both the upper and bottom or lower 9 by 9 grid. This means that if we were to look at column 7, column 8, we see a 4, 1, 9 on top, and can know that 4, 1, 9 will not be in the middle 6 squares. We can only find 4, 1, 9 in the bottom 3 rows in the same column. Now using cross hatching, I do see a 9 in column 10, row 10. I know I cannot put a 9 in row 10. I put the 9 in row 11 instead, and then, whoops, and then put the 4 in row 10. If I were to look at the middle 6 numbers in column 8, I would know I am missing a 2 and an 8. If I look at row 4, I see 2 8s. This tells me I must put the 2 in row 4 and the 8 in row 7. Now let's go around the grid and fill in the outers, as that would be easy to do. I just wanted to point out some key features of the middle 6 numbers in any row or column. Okay, looking at row 3, we see a 7 and a 1. The outer, the fourth grid also has a 1 and a 7. However, this is a 3 by 3 grid, which is only missing one number, so I count and fill in the 3. No sense in having a grid if I'm not going to use it. Rolling for laughter, folks. Row 4 has a 8-4 combo, and the outer fourth grid has a 5-8 combo. I can merely put the 5 in column 1 and the 4 in column 10. Moving on down to row 5, we have the 1-3-2 combo, and in the fourth grid we have 2-1-3. Same numbers, different order. Now row 6. Row 6 only has a 9-6 combo. And the fourth grid only has a 6. I look at column 10 and see a 9. So I know that column 10 cannot take the 9 I want to place. So I put my 9 in column 11. I see I only have one missing number, so I count and find I need the 7 and put it in both the in both outer grids. Columns 3 and 10, if you're wondering. Okay, row 7 has a 5 in the outer on the left and a 4 5 in the fourth grid on the far right. I look at column 1 and see a 4, so I put my 4 in column 2 instead. Now I am missing 3 numbers in this box, 3 by 3 grid on the left, or should say on the right, and missing 4 numbers on the left grid. I'll look at the right grid instead. I need a 2, 3, and an 8. If I look at column 10, I see a 2, but no 8. Looking at column 11, I see a 3 and an 8. This means I know that a 2 must go in row 8. This does not tell me where the 3 and 8 go. However, if I look at row 7, I do see an 8 in the middle 6. This means that I cannot put an 8 in row 7. Thus, row 7 must take the 3 and row 8 must take the 8. we cannot put any number in the middle six squares into the outer six squares, either the first three squares on the left or the outer three squares on the far right. This also applies to the top three squares and the bottom three squares within any column. This is why in column 10 we do not see a 9, 5, or 1 in the middle six squares. Within the same column 10. This is also true for columns 11 and 12. So looking again at row 7, we know we can put in the 3, and in row 8 we can also fill in those numbers after we look at the columns to see which number goes where. Because column 2 had an 8, I put the 8 in column 1 and the 2 in column 2. Then I simply put in the 6, as that's the last number left. Row 11, I see a 1, 3, 7 on the far right. So I merely put in the 3 that is missing on the far left. Row 12, I see a 4 square 6, and in the fourth grid on the far right, I see a 5, 6, 4. This means I can put the 5 in the far left column 2, row 12. Now looking at the columns, column 1 through 3 are done. I move on to column 4. I see a 5, 9, 4 combo, and look at the fourth grid and put in the 4. Column 5 has a 6 and 3 combo, and the fourth grid has the same numbers. And this isn't the only missing number, so I will move on to column 7, 6 rather, 6, to see if it has any help. I see a 1-7 combo, both on top and bottom. Column 8 has a 4-1-9 all in. Column 9 has a 7 and a 6 on top and a 2 on the bottom in the fourth grid. I put the 2 on top and then look at the rows for a 6 or 7. I put the 7 in row 10, column 9, and the 6 in row 11. Now let's go back to column 7. I merely count the numbers in order to find the missing number. 1, 2, 3. 1, 2, and 3 is missing. I also see that on top is a 3. So obviously this gets a 3. I also see a 5, so I know that I can put a 5 down here. And then put the 8 on top. Okay, column 5. 5 and 6, 3 columns. Are missing the 2 and 8. Neither column has a 2 or an 8, so I can't really place those numbers yet. Moving on. Let's look at not sure. Row 4. Row 4 has the one missing number to make it easy for us. Now we know that the inner six squares cannot have any number found in the outer 3 squares on the left or on the right. Thus, we count 1, 2, 3, 4, 5, 6, 7, 8, and the 9 is missing. Moving on to row 9. We are missing the 3 and 8. Notice that in the 3 by 3 grid, we have an 8 here. That means I must put the 8 in column 6 instead, and put the 3 in column 9. Now looking down column 6, we know that we can't put another 8 here, as an 8 in the middle 6 cannot also go in the outer 3. Thus, I can put the 2 in column 6 and the 8 in column 5. Okay, moving on up to row 8, we are missing the 3 and the 9. I see the 9 in this 3 by 3 grid, so I put the 3 here and the 9 in the other spot. This leaves us with one missing number, in this 3 by 3 grid, the 6, so I put it in. Then moving on over in row 7, I am missing a 2 and 7. I look at column 4 and do not find a 2 or a 7, but in column 5 I do see a 7. We'll put the 2 in column 5 and the 7 in column 4. Row 6 has lots of goodies for us, but I noticed that column 5 and 6 in row 3 are empty. Now I know I must put the 8 in column 5 and the 2 in column 6. So let's put those in real quick. Now row 6 has 5 missing numbers, but if we were to look at the columns instead, we would know that we are only missing one number in each column. This should only take mere counting to figure it out. No 2 in column 4. No 2 in column 4. Column 5 is missing the 1. Column 9 is missing the 8. Column 7 is missing the 4. And column 6 was missing the 5. And we have solved an easy butterfly Sudoku puzzle. Thank you for solving this one with me. Please like, subscribe, and share. I hugely appreciate it. Thanks again and have a wonderful day. Bye.